All right, folks, welcome to the stream. In just a moment, we'll begin. Gonna verify everything is working well here and grab the chat. All right, let's see here. All right, I think we're good to go. Just let me know in the chat if there's any issues with the volume levels or that sort of thing. All right, so tonight I'm going to be briefly debunking some nonsense that has been going around about 3i Atlas. I have about half an hour here while my salmon smokes in the smoker out back, so apologies, this is going to be a very quick stream, but I'm going to do a quick hit here on an issue that I've seen happening for months now on social media with people claiming that this image down here by Dobsonian Power shows something unusual, that this is 3i Atlas captured when the comet was near the sun and not visible to most observers. And it's been circulating once again. So earlier today, Black Hole posted that image again, or a processed version of that image, claiming that it shows traces of industrial grade metal casting doubt on a natural explanation. So I had been wanting to debunk this, but just hadn't gotten around to it. But this finally motivated me to do something about this. So I recreated a very similar effect in my own images of 3i Atlas and posted it here on Twitter earlier today. And mentioned the fact that I processed it with various upscaling and denoising techniques, very consistent with the image taken by allegedly by Dobsonian Power. I've seen it attributed to a couple people. I'm not 100% sure if this particular one really comes from Dobsonian Power. I believe it does, but there has been some conflicting information. So apologies if I'm getting the attribution wrong, but to the best of my knowledge, this was taken by Dobsonian Power. So I did my own version using my own images of 3i Atlas, and I mentioned that I would be addressing the pitfalls of bad flat field calibration in a stream on my channel, because that's what this actually is. Now, I've had people misunderstand this post and think that I was sincerely saying that this is what 3i Atlas currently looks like. I even had friendly fire from someone who follows me, who I believe is related to Unistellar, and thought that I was just posting an out of focus image, which is very common. You see this kind of circle of confusion taking on the shape of the optics of a telescope, and usually that's an indication the image is out of focus. So I pointed out actually that the properly calibrated and stacked version of the picture doesn't show that. It's not out of focus at all. In fact, everything's in focus. That's not the problem. The problem is that the flat field calibration is bad. So what is flat field calibration? So let's talk about that. But just one more thing. It turns out that it wasn't only I wasn't only catching friendly fire. 3i Atlas Whistleblower, who is an account that posts a lot of pseudoscience, to be honest, and a lot of nonsense about 3i Atlas, reposted my picture and tagged me. Again, he or she seems to think that I was posting this as if this really reflects the true shape of Comet Atlas right now. But as I mentioned, the purpose of this was to address the pitfalls of bad flat field calibration. So he posted this. Apologies if it's supposed to be she, but this account posted this, sincerely believing that I was presenting this as if this was a good image of 3i Atlas. And when I tried to reply with a link to this stream, I found out that the post has been deleted. I think they realized a moment later, especially when looking at my replies and the fact that I mentioned that with proper calibration, that's not what you see. They realized they got had. They took the bait and didn't pay close attention to what I was actually saying, which is just it tells you something about the reliability of their information. But they admit that this is exactly like what they were seeing previously by Dobsonian power. They even referenced it and posted previously captured by Dobsonian power down here. So I'm glad they admit that this looks like the same thing. Very nice. I'm very glad to see that because I have a feeling they're going to backpedal from that position very, very quickly after this stream. So yeah, an angry astronaut's been yakking. So Andrew Kroll says in the chat, angry astronaut's been yakking about the BS about 3EI Atlas for weeks now. It's pathetic. Yeah, I do want to address something with a recent video from him too. I don't know if I'll have time tonight, but we'll get there. So let's address this. So first of all, let's talk about what flat field calibration is, why we need it, all of that good stuff. So let me bring over Deep Sky Stacker over here so you guys can see. These are the pictures of 3i Atlas that produced that image, okay? This is the raw, uncalibrated image from the telescope. Now, there's a number of problems with this image. It is calibrated in terms of dark. There's been a dark frame applied, so most of the hot pixels are now gone. But you've got vignetting at the corners, this darkening at the corners. You've got dust motes on the CCD. You see these dark spots here and here, here and here. These are dust motes in the optical train, generally on or near the CCD. The CCD is the sensor in the camera. And if any dust or debris is on that sensor, it will be just above the point of focus, essentially. And so it will take on a circle of confusion shape, which in the case of these images, it takes on this donut shape. You can see here, if I zoom in, it's a little hard to see because it's so grainy, but you can see in the magnified view there, that dark donut. So that is because we are shooting here with a Schmidt-Cassegrain telescope. This was shot with my 8-inch Schmidt-Cassegrain LX200, so it takes on the shape of the optics, the primary mirror, which has a hole in the middle through which the light passes. So you get this donut shape. So that's because the dust, of course, is not in focus. It's slightly out of focus, and it's creating this slight dark blur on the picture. So how do we solve this? Dobsonian Power had a number of live streams about 3i Atlas months ago where he claimed to be showing 3i Atlas through a solar filter looking at the coordinates of 3i Atlas very close to the sun, and he saw something. Well, any dust in the optical train is going to manifest as a dust mote in the resulting image. And in his case, I believe he was using a refractor, so it wouldn't necessarily be a donut. However, he may or may not have been applying a flat field frame at some point. And then I heard him say in one of his streams that he had cleaned it. He cleaned the sensor, so if he still saw it, it must not be dust. Well, okay. That assumes you did a perfect job cleaning, which is not trivial to do when there may be multiple elements within your lenses, within the optical train that may contain that dust that may cause the issue. And even if you try to clean the sensor, and even if it's on the sensor, maybe it evades cleaning and is still there. Maybe its position is only slightly shifted. So what happens when you try to calibrate with a flat field? Well, if you have a good flat field image, this should all get taken out. You should be able to resolve the issue with the vignetting. You should be able to resolve the issue with the dust motes on the CCD. That's how you really should do it. Instead of trying to scour your lenses and optical elements and CCD every single time you image to make sure there's no dust, as an amateur, you should just take flat field calibration frames, honestly. And there are a variety of ways to do flat field calibration. So a flat field is where there's nothing in the frame but light, not the target, but just a reference frame of what is in the image in terms of dust, and other things like that. So if I show you here, this is a flat field frame. You see those same dust motes in the middle, and there's a bit of vignetting. This was a picture, I believe this one was probably taken pointed with the telescope pointed down at the yard. You want an even illumination. Uh, in the absence of a proper light panel, any sort of evenly lit target that's close to the telescope will suffice for rough purposes. And that's what I did here. So pointed the telescope down at the grass, took a picture with the focus exactly the same as it was, and recorded those as flat fields. There's another way you can do it, which is using the sky itself, especially at twilight. So as the sun starts to come up and you lose sight of the stars, you can just take a picture of the twilight sky, preferably away from the east as the sun's coming up, sort of overhead where you have even illumination. You want to try to make the illumination as even as possible, but hopefully bright enough that you're not picking up stars, or if you are, take many pictures, do a median stack, which you should be taking many pictures and stacking the flats anyway. And you want to do that. You could potentially even do that with multiple stars streaking through, as long as you have enough to completely take them out with median stacking. You can get rid of the stars in the final stacked flat, and then you have a reference image from the sky. So we call that a sky flat. Well, if you're taking pictures during the day through a solar filter and you're pointing away from the sun, you're potentially not actually seeing anything real at all. You're effectively taking sky flats the whole time. Um, and so any dust in the sensor, any dust in the system will manifest like this. You'll see something like this. Now, if you try to calibrate this with a flat field after you've already tried to clean it, the dust may not be in exactly the same position, even if it's sticky. It may shift slightly. And so the reference for where the dust is in the flat field is no longer accurately reflecting where it is in your light images that you're trying to apply the flats to. This results in weird looking artifacts in the resulting image. And I'm going to show you guys what that looks like now, because in reality, these flats, although these were good flats for the night I was shooting, the optical system was set up slightly differently. I had a different setup there with a focal reducer applied in these 3i Atlas photos that was not in place during the shooting of these flats. So I'm deliberately going to calibrate improperly using a bad flat. This is simulating what would happen if I, say, tried to clean the sensor and move the dust around slightly, or if I tried to use maybe, say, flat field images from years ago where the dust wasn't quite in the same position, and stack it and try to calibrate it that way. It's not going to accurately remove the dust from the resulting image. So I'm going to go ahead and hit stack here, and I'm going to go ahead and stack these frames. So there's just 6 images of the comet here in this case, and here's the result. So it looks very dark, so we need to adjust the histogram. So we need to adjust the contrast and the brightness of the image. So we'll do that. And bring the brightness up like this. Okay. So there we go. So now with an improper flat, we still have residual parts of the donut visible in the resulting image. This is actually 3i Atlas over here, which is slightly elongated because I'm actually stacking on the stars. And we'll get to that in a minute. But here and here, we still have residual dust motes. And so I've done some processing and some versions of these pictures. So I'll bring these up so you can see what that looks like. So here's one that I processed in Graxpert and Cyril. Graxpert denoising didn't really work too well. There's a lot of residual noise that kind of looks like a star field, but it's just residual noise after denoising. But you see these weird shapes here near the comet. Well, that's not 3i Atlas, and that's not a real object at all. That's actually dust on the CCD that has not been correctly subtracted. So what's going on here? Well, because in my case, I have a focal reducer in one set of images and not in the other, the dust mote shape, that donut, is slightly different in those two different pictures. And so because the flat is basically making anything that looks dark in the flat brighter to compensate for the loss of light due to the dust, If the dust looks darker than it should, it's going to make the resulting donut go inverted. Instead of being a dark shape in the image, it's going to be brighter. Or if the dust moves, now it's going to create a bright shape instead of a dark shape. So it's going to invert the brightness of the dust in the flat in the resulting image. And so you have what looks like an object in the image, but there's no object actually there. It's just dust that has been improperly corrected for in the resulting calibrated, quote unquote, calibrated files. And so that's exactly what happened. And so I did a variety of upscaling and denoising techniques with Cyril, with Graxper, and layered on the non-denoised version as well. And so yeah, and then did an AI upscaling, and you get this crazy looking thing. And really, what is this? This is just dust. This is just dust, and the result of bad flat calibration, whether that's by trying to attack the sensor with a cleaning effort and then go at it again and maybe try to do flat calibration, with flats taken before the cleaning effort and then applying it to images taken after the cleaning effort. All of this can produce this kind of artifacting, and it can look quite wild. And so the exact shape of what it looks like is going to depend, of course, on exactly what you did with it. How did you, how did you muck it up, essentially? So here's another example. This is from a different set of images that I took of M51, where again, I applied an inappropriate set of flat fields from the same camera, mind you, exact same camera, but with a slightly different optical configuration, and you get what looks like a black hole in the picture. Elsewhere in the picture, you get this shape. So you can get very strange looking artifacts as a result of inappropriate flat field calibration, which is exactly what we see in the Dobsonian power picture. And this is again why I think it's kind of cool that 3i Atlas whistleblower completely accepted that as a premise and said, yeah, this strangely looks like what was previously captured by Dobsonian power. I agree. I absolutely agree. Unfortunately, we know exactly what it is, and it's not anything in the sky at all. It's actually just dust and the sensor producing an artifact that has this kind of shape. So even if you're not using a catadioptric, even if you're using a refractor, and you do a bad flat field calibration like this, you can get varying shapes that can look like this. And it just depends on exactly what you did to it to cause that. Uh, so yeah, this is not anything abnormal. So let me show you what the picture looks like when you correctly calibrate it. So this is the same picture aligned on the comet in this case, and with a proper set of flats applied. And now you don't see the dust motes at all. They're completely gone because they're correctly subtracted. And so what I did during the acquisition of these images is I moved the telescope every few minutes to a slightly different position and took another set of images as the comet continued moving. Ultimately, they'd all be aligned on the comet. But what this allowed me to do is take the lowest value across all the images with the comet and the stars, each in slightly different positions over each pointing of the telescope, and take the lowest value relative to the median of the image and be able to construct an appropriate sky flat, essentially. And so that's what I did with this process here, and here's the result. So looks good, no issues there. But some people are also posting pictures not aligned on the comet, but aligned on the stars. So this is from the same image set. This is from the same series of data from the same night, but aligned on the stars instead of the comet. And what you see is the comet makes this bright, fuzzy streak through the image. Again, with appropriate flats applied, you don't see the dust motes. You just see the stars and the comet. And so some have been making hay out of images of Comet Atlas that are not actually unusual or hard to understand at all. Angry Astronaut even pointed out an image like this a couple days ago. He did say that he believed it could be due to motion blurring of the comet over the course of the images, but that's definitely what it is. Like there's no question about it. That is immediately identifiable as what it is. So I'll bring his video up here and let you guys listen to what he had to say. Oh, it's not playing the audio, is it? It's most curious.
A fascinating image.
Yeah, there we go. All right, let me turn that down just a bit so it's not maxing out. All right, let's go again.
This is the one that's been attracting the greatest attention as of late, and for very good reason. This doesn't look like a comet at all. This doesn't even look like a comet extended out by its tail or anything along those lines. This looks like something completely unique, but it's very difficult to explain why it looks this way. Again, very, very strange. This was captured, by the way, by Paul Craggs on November the 21st, and this image may be modified by motion smearing of the image overall. Keep in mind the 3-eye atlas is in motion, actually moving very, very quickly, and this time exposure photograph shows all of the stars as these beautiful little pinpoints, whereas 3-eye atlas is definitely moving relative to the stars. Now, it's possible that the time exposure photograph might be able to account for these differences in speed of the surrounding objects in order to create a prettier image, and if that's the case, then that's what 3-eye atlas actually look like at that particular moment. But I think it's very possible that this is just due to a trick of time exposure photography rather than something real and radically different from everything we've seen thus far. But what can
So yeah, I'm sorry, it just frustrates me that he sort of couches it as, well, he gives the correct explanation. It is that the comet is moving relative to the stars, and the images here are tracked and stacked on the stars. So that's why the comet is this motion blurred object. But he couches it as a maybe, as well, maybe that's the explanation. No, that's definitely the explanation. And you can see it in my example, a very similar effect when I align on the stars. And you can see what the stars look like in that example. As he points out, they look like pinpoints. That should be your first clue. Like, that's a red flag that, hey, if you see the comet looking like a streak, that's because the images are being tracked and aligned on the stars, not on the comet. Same set of images, but when we align on the comet, this is what we get. Now one's inverted, relative to the other, but the same idea here. You can see the streaks of the stars. You can even see a little gap in the streaks where I pause to reposition the telescope briefly. So you can even see interruptions in the sequence of images if there are any to be seen, and you'll see that in the resulting streak. So if I go back to the streak of Atlas, it's a little hard to see, but that same interruption is right here in the Atlas streak. But that's an effect of the comet's motion relative to the background stars. The comet should look like this relative to the background stars, unless the picture has been processed to essentially merge these two different kinds of stacks, merging a stack that was aligned on the comet and a stack that was aligned on the stars. In fact, Deep Sky Stacker has that as a built-in option. You can pick that as a stacking option or parameter. So when you stack on a comet, it'll give you the option of stacking on the stars, ignoring the comet position. If you've labeled the comet in each of the pictures, you can stack on the comet itself, and of course the stars will be streaked. Or you can have Deep Sky Stacker automatically merge those two different kinds of stacks and basically try to layer the picture of the comet, the picture of the comet stacked on the comet over a stack aligned on the stars to basically undo the motion blur on both. Generally, this doesn't work great in my experience. It's kind of an approximate first pass, but needs a lot of cleanup. but it gives you an idea of what that looks like anyway. So I'll just do that right now and see how that looks. Now it's going to have the inappropriate flats applied, so that might be interesting. But we'll take a quick look at that. So let me just bring up the brightness here. So yeah, you can see some residual dust mote stuff going on there. But you can see, okay, so the stars are now more pinpoint. The comet is kind of a merge between a blob, fuzzy blob and a streak. So it's not perfect with Deep Sky Stacker, but that's basically what people are doing. Usually they are doing that by hand themselves after doing the two different kinds of stacks. But yeah, that's a default option even within Deep Sky Stacker. But if you're seeing, if you're seeing a picture where the stars are pinpoint and you see this elongated streak, well, that's generally because of the motion of the comet, not because of, well, it's not because that's what the comet actually looks like. It's that these pictures were taken over 20 something minutes of time and the comet moved during that period of time. So yeah, just a couple items I wanted to address. Again, thanks for the shout out there through Atlas Whistleblower. Yeah, I agree with you. That does look like what Dobsonian Power posted, but we understand what that is, and it's due to bad, inappropriate, flat calibration of the images, and that's just an artifact of incorrect calibration of the images. That's it. All right, so let me check the chat. Any questions here before we go? Not seeing much. So it's not a tear in the space-time continuum. Nope. And it's not even that hard to understand, truly. But yeah, there's a lot more nonsense out there about 3i Atlas, of course, claiming that it's a alien spaceship or that something about its appearance is inexplicable. It's definitely unusual as comets go because it's not from our solar system. It is an interstellar comet that is passing through our solar system, but it's not from around here, and so its composition is going to be different. It's spent probably the lifespan of our solar system being bombarded by galactic cosmic rays and nothing else. So it's not like the comets we have in our solar system. Uh, and the original makeup of the composition of its origin solar system may be radically different from ours. So it's not unexpected that it throws curveballs at us in terms of some of its particulars. For example, it has a bit of an anti-tail. Let me see if I can pull up my own tweet about that. So it's not the first comet to have an anti-tail, a tail that faces the sun, paradoxically, instead of facing away from the sun. That can happen for a variety of reasons. Some of them are an optical illusion of passing through the plane of the orbit, but others can be due to larger dust particles that are not as easily pushed away by solar radiation pressure that are seemingly pointing towards the sun because that's where it's outgassing. But it's outgassing with larger particles of dust that are not as easily pushed back by solar radiation pressure. So when I did some imaging of it, about a week ago, and did a live stream of it, I collected images 2x2 binning for greater sensitivity, and then did rotational gradient processing, which is a way of revealing jets from the comet. And what we saw was, first of all, in this direction, this is facing towards the sun. So we see a prominent anti-tail, essentially, and a jet facing away from, facing towards the sun, coming off of the comet. We also see what looks to me like a jet about 90 degrees away from that, not nearly as prominent, but visible here. And you can see this is just a different coloration based on the intensity of the image, seemingly facing away here, and maybe starting to be blown back a bit by solar radiation pressure. And then, of course, we have the hint of a tail pointing away from the sun in the normal sort of orientation. So there's probably a distribution of dust particle sizes coming off of the comet, some of them large enough that they are not being affected as much by solar radiation pressure, others are. So that doesn't mean it's not a comet, it's just not as typical of a comet that we would normally see in our solar system, but it is nevertheless a comet. Like, this is clearly what a comet looks like. Most people don't realize that, but like there's many comets in any given year that are relatively minor that don't have prominent ion or dust tails that just mostly look like a fuzzy coma like this. And if you do some, like I said, rotational gradient processing, you may start to reveal jets or hints of a tail facing away from the sun, as I did here. But the comet that I discovered back in 2016, P2016J3, which is now labeled as 414P, made a pass by perihelion earlier this year, and I captured it, and it looked much like this. Didn't show a tail. It was not detectable. There was no tail detectable even to my 11-inch telescope. That doesn't mean it's not a comet. That's actually quite typical for what I would call a minor comet, or something that's not as prominent. Now, 3i Atlas did show a wispy, faint tail that was detectable to larger telescopes than mine earlier a few weeks ago as it emerged from behind the sun. Uh, but it's now getting further from the sun, and so its activity should gradually decrease over time as it gets further away from the sun, even as Earth gets closer to it. So Earth is getting closer to it over time right now, and it will potentially become more visible as it moves away from the sun in the sky, but it may not show as much activity, and it may not show a prominent tail that people are expecting to see. And so there are some grifters, unfortunately, who are trying to capitalize on that and say that that is proof it's not even a comet, it's some, alien spaceship coming into our solar system. We've discussed before some of the issues I've had with Avi Loeb, and really my biggest issue with him has been that when he's made a mistake, like when he mistook Phobos in the navcam images of the Mars rover for 3i Atlas, he quietly edited his own article after my live stream on it. And I'm not saying it's because he saw my live stream in particular, but there were many people pointing out the fact that that was actually Phobos, not Atlas. And he quietly edited it to say that people on social media were claiming it was Atlas. Well, his previous version of the article flat out said it was 3i Atlas. So I have an issue with that when someone gets things wrong and they don't issue a proper retraction but try to quietly edit their own statements to seem like they never got it wrong in the first place. That's a real problem. I have a problem with that as a fellow scientist. So, um, yeah, there's a lot to discuss, and we've got issues now with AI generated Avi Loeb making false statements on various channels. So my own parents sent me a link to a YouTube video, and I looked at it, and something seemed off about it. I put it through AI detection. Sure enough, it was AI generated. And if you look at the clock in the background of the video, like, it's nonsensical. It's not a real clock because it's AI generated based on actual footage of Avi Loeb. So there are lots of people unfortunately falling for that, um, because they know Avi Loeb, or Avi Loeb has become quite popular as an expert on this subject, but in reality he's gotten things wrong too. But it's plausible, right, that he would say something about it being an alien spaceship because that's been in the news. And so there's AI generated channels that are running with that and grifting off that. So it's a big problem. There's more to address, and I hope to do that in future live streams. So if you liked what you see, please subscribe for more. And until next time, thanks for watching, and clear skies.